So guys, as an engineer who is getting to work on a code base which is concurrent, it is very instrumental to figure out the compound actions inside your code so that you can protect them, so that you can guard them by using some sort of locking mechanism. Okay, so I wanted to give you more examples of compound actions, something like check then act. So if you remember or if you have heard of something called as a Singleton class, you will relate much more to it. In fact, if you have done low-level design course with us, you would already have learned this there. So basically, a class is a Singleton class if it guarantees that in the runtime environment, there will be only one object of that class in action. So if let's say there are multiple other classes that needs an instance of this Singleton class, which is employee ID stored, then they'll not be able to make new instances. They'll be able to reuse an instance which is already created. Okay, that's the idea. And so I'll not be getting into the details of Singleton class and pros and cons of it. But as you can see here, what we have done is we have made the constructor as private. Now, because the constructor is private, so it cannot be invoked from outside the class. So no other class can do new of employee ID store. It will be illegal. And what we have done is, in order to instantiate, we have created a method called as getInstance, which is static by nature, so that you can just do employee ID store dot getInstance. You don't need an object to invoke it, right? Because it's static. Now just read through the logic present over here. What do you think? Is it a compound action and can it result in issues? Just pause and think. Okay, so let's look at it. Let's say your thread 1 is scheduled and thread 1 gets inside this getInstance method. Now, when it gets inside this method, it sees that currently the instance is null because that is what we have initialized it to. Now, let's say CPU scheduled some other thread which got inside and that also saw that instance is equal to null. But wait. Thread 1, which had already seen that the instance is null, would now, in the next step, whenever it is scheduled, would go ahead and create an object of it, right? And after that, when thread 2 comes back, it will also end up creating another object of it. So now, in your runtime environment, in fact, instead of just one object, there will be two objects that will be floating around. And this can be disastrous. Why? Because most of the times you go ahead and make a class as Singleton if the object corresponding to that is humongous, is huge. So like here you can see, whenever we do new of employee ID store, we are going to read the database and we are going to populate a huge hash map with details of our employees. Now, let's say if I only have sufficient memory for one instance, in that case, if by mistake two instances are created, it will lead us to memory issue. Okay, you might run out of memory. So if you inspect this thing, what is this? This is check then act. The first thread checked that the instance is null and then it wanted to act. But during that time, a context switch had happened in between, right? So the check that other thread made, that was actually stale. Okay, so this is the issue that gets arisen. So the point that I'm trying to come over to is that whenever you have scenarios like these, where you are doing some check inside if and based on that you are taking an action, just make sure that tomorrow if your program gets multi-threaded, it will behave weird. Okay, cool. So let's go ahead and look at some other scenario now. Okay, so here is a piece of code that I want to show you. So there is a class called as event container. Now imagine Programming Pathshala wants to do some public events for free on social medias. So for every event, there will be a title that, this is an event on low-level design. And then there will be a syllabus corresponding to it. So in this event, we will be taught solid principles, for example. Now, on the next week, there may be some other event. Let's say there is an event on high-level design, and there the syllabus is to learn about caching. Okay, so I have created a class called as event container, which encapsulates these two things, which are event title and event syllabus. Okay, cool. Now, let's say Programming Pathshala organizes these events on a round robin manner. So let's say we have 7 different events. So in the first week, we conduct event 1, then in the next week, event 2, then 3, 4, 5, 6, 7, and then in the 8th week, we start back from event 1. So this is the kind of system that we want to basically build. Okay, so you can see that inside this event container, we have a method called as increment. Okay, I'll just go ahead and comment some piece of code for now. Just don't look at them for now. So here what we are doing is, whenever this increment method will be invoked, then we will basically move our container to the next event. Okay, and moving to the next event means that we want to move on to the next title and also the next syllabus. That is exactly what we have done. Okay, and we have a get method. This get method simply gets the title and gets the syllabus, crafts a beautiful string out of it and returns that string. Okay, cool. So at this point of time, you might want to take a look at event title. So event title is a class which contains a vector of strings, a list of strings in which, every string denotes a title of a certain event, right? And then there is a counter present over here. Initially, the counter is 0. Now, whenever you call next, what we do is we do count equals to count plus 1 mod the size of list. Now, you understand why we are doing this, because we want our events to happen in a round robin manner. This is why we are doing this thing. Also, I have kept it synchronized because, there is this variable counter which is getting changed. And if there are multiple threads that are accessing it, they might lead to race conditions and all. So I prefer to make it synchronized. Okay, we also have event syllabus, which is pretty much the same. Now, it also has the same list of strings. But here, instead of event name, it holds the syllabus, which will be covered as a part of that event. That's it. Okay. And it also has a counter, and it also works in the exact same manner. It has a get method, which returns the syllabus that we are pointing to at that time. And if you remember, event title also has a get method that does pretty much the same thing. Okay. So now if you head back to event container, inside our increment method, all that we are doing is title.next, and then we are doing syllabus.next. Okay. Now see, this is not synchronized. I have not acquired any sort of lock over here. But the next method, which is present inside title, that is synchronized. And the next method, which is present inside syllabus, that is also synchronized. Okay, cool. You can see that here. Okay. Now, can there be certain issues? Just pause the video and think about it. The answer is yes. Because incrementing our event from one event to the next event is like a compound action where we are incrementing our title also and incrementing our syllabus also. Now, it is not enough to make both of them individually thread safe. I have to make this entire thing as a thread safe action, failing to which, do you know what can happen? So let me show you a main program that I have written. So I have created an event container, which some event title and event syllabus. So if you look at the code of event title and syllabus, you will see that the counters are initialized to 0. So what is there at 0? Let's look at that. At 0, we have got DSA event for which the syllabus is this, right? Okay, let's come back to main. So now the first thing that I have done is till now, my main thread has not launched any other thread. So if I call container.get, we all know that this get method will be invoked, and title.get will get us DSA, and syllabus.get will get us the syllabus corresponding to DSA. Okay, so that is the expected behavior so far. Okay, now we have created a new thread. Okay, injected this container inside its worker, and then we have launched that thread. Okay, we have launched that thread. Cool. And after launching this thread, what we have done is we have slept for some amount of time, and after that we have printed certain thing. So let me run this code and we will see what happens. So as we might be guessing already, this line will behave normally. Why? Because so far the code is sequential, so it will print that the title is DSA and the syllabus is so and so, right? On the other hand, if we go ahead and look at what has been printed over here, then here it is LLD followed by the contents of LLD. So far, so good. There is no problem at all with it. But think about a scenario where a certain thread got scheduled and it changed your title from DSA to LLD. Now, before it could execute this line, a context switch happened, and during that context switch, some other thread got scheduled which made a call to get. Now, when it makes a call to get, what will happen? It will see that the title has been changed to LLD, but the syllabus hasn't been changed yet. And let me simulate that scenario for you. So if I just uncomment this piece of line, what will happen? The thread that I had launched from main thread, it will change the title from DSA to LLD and then it will go to sleep. While it is in sleep, the other thread, which is main thread, will be scheduled, and that main thread, in fact, I had made that main thread also sleep for a while, but the other thread is sleeping for 4 seconds and this is sleeping for only 2 seconds. So this will wake up before the other one. And then it will make a call to get. When it makes a call to get, it will see that the title has been changed, but the syllabus is undisturbed. So if I just run this piece of code, that is the behavior that I would expect. Let's see what happens. And we can see that is exactly what has happened. You can see that the title has changed, but syllabus has remained the same. So guys, I want you to understand that whenever you look at classes like these, which hold certain state or which hold certain invariants, those invariants have to be consistent. If they are not consistent, they will point to some erroneous scenario like what we can see over here, right? So it's very, very important that our invariants are always consistent whenever they are read. There should not be any consistency issue with them. Okay, that means that, hey, if I make this thing as synchronized, then it would be better. And yes, of course, you should make this thing as synchronized, because if you fail to make this thing synchronized, in that case, we know that a thread which has first executed this thing might then be replaced by some other thread which tries to read the data or which tries to do some other sort of thing, okay, which can lead to the corruption of invariants basically. Okay, one more thing. Is this going to solve the problem entirely for us? Just pause and think about it. Okay, let me run the piece of code. We can see, no, the problem is still there. Why the problem is still there? Because while one thread has acquired a lock, during that time, if other thread gets scheduled, it can very well call get and get the inconsistent string. Why? Because get does not require some lock, right? So do you see what is happening over here? We are basically printing some corrupted data because the invariants are not in consistent state. So whenever scenarios like these arise, there you might want to synchronize your get also in the same manner in which you are synchronizing your write operation. Both your read and write needs to be synchronized here. So this is first such example, but in the time to come, you will see many such examples for sure. In fact, you will realize that it's very important to synchronize our read methods with the same lock that you are using for write methods. You will get the reason to that in the time to come. But for now, if I perform this change and then go ahead and run this piece of code, then you can see we are getting exactly correct output. And why is that happening? You can think about it. Because the moment context switch happened and main thread came to action, now main thread made a call to get. When it made a call to get, it realized that it needs to take lock on the object of container. But it found that, hey, it can't acquire it because that is already acquired by thread T1. So now, of course, thread T1 will be scheduled and thread T1 will be scheduled after 4 seconds, so be it. It'll have to wait for that. Main thread will have to wait for that. And then it'll increment the syllabus, release the lock, and then that lock will be acquired by this, and then it will go ahead and print this thing. Okay. So I understand that here it looks like I have made everything very much sequential in nature, but that was not the point. The point was that compound actions can lead to corruption of invariants if not done in a thread safe manner. Okay. And we have seen some examples of that. In the time to come, we'll be seeing many more examples. But for now, just think of some compound actions that you might have written in programs that you usually write, and how you can just go ahead and prevent that by using simple synchronized blocks.